Hello everyone. In our previous sessions, so far we have learned many things in trigonometry. We have also understood well that these 6 trigonometric ratios are the core of trigonometry, where sine, cos, tan are called basic trigonometric ratios, as the other 3 are just reverse. So we write them as. We also know that tan is the ratio of sine and cos, so we write cot as cos upon sine. These relations are true for every single value of theta and are called trigonometric identities. Identities look like equations that have 2 equal sides. So please remember, there is difference between an equation and an identity. To understand the difference completely, look at these 2 expressions. If we look at the first, both the sides will be equal only when the value of x is 3, whereas the other expression is true for any value of x. So the first expression is an equation and the other is an identity. Likewise, if we take any trigonometric expression, say 3 plus sine theta equals to 4, this is true only when theta is equal to 90 degree. On the other hand, sin theta equals to 1 upon cosec theta is true for every single value of theta. Therefore, it's very much important to know the difference that an equation is true only for certain values of the variables, whereas an identity is the special equation which is true for all the values of the variable. I hope now it's clear that what is an equation and what is an identity. Also, the word identity is not new for us. In our lower grades, we have learned as well as used some of the identities. But these are called algebraic identities. Algebraic because these expressions contain only numbers, letters and arithmetic operations. But we might also be thinking, where do we use trigonometric identity? Trigonometric identities are used in civil engineering, mechanical engineering, and these are used heavily in architecture, especially in developing large infrastructure. So like this, there are many more uses, but that we will learn as we proceed further in our higher grades of mathematics. Right now we will see how these identities help us in simplifying the huge expressions involving trigonometric ratios. Let's take few examples. We can see that the left hand side is the huge expression which has been reduced to a comparatively small value on our right hand side. And equality sign in between indicates that both sides are equal in values. So let's see how can we use these basic trigonometric identities to solve these questions. So in first question, we consider left hand side and we know that the value of sine 90 is 1. Now, values for sine 70, cosec 70 are not available in our standard value table. But we know the identity, cosec theta is equal to 1 upon sine theta. So, we can replace cosec 70 by 1 upon sine 70. Sine 70 upon sine 70 will give us 1 and adding it with 1 will give us the answer as 2, which is equal to the right hand side value. So, we see how the calculations become easier just by knowing the basic trigonometric identities. Similarly, even in the next question, we can either write tan as 1 upon cot or cot as 1 upon tan. Let me write tan as 1 upon cot. We keep sin theta as it is because our final answer should look like expression in our right hand side, that is 1 plus sin theta. Again we can write sec in terms of cos or cos in terms of sec. So again we have got left hand side equal to the right hand side value. Let's now consider the left hand side of the last question. I know it is quite bigger than the first 2, but don't be afraid, it is very much easy to solve. We can see sin 90 minus theta and cos 90 minus theta. So let's use the concept of complementary angles to write down everything in the form of sin theta and cos theta. So cos 90 minus theta will be equal to sin theta and sine 90 minus theta will be equal to cos theta. Also, here we use the identity sec theta is equal to 1 upon cos theta. Now to simplify further, we write sin theta into sin theta as sin theta the whole square. So this will be equal to cos theta the whole square. And we know the identity sin upon cos is tan. One more very important point that we should know is sin theta the whole square is equal to sin square theta and not sin theta square. So by using this fact, we can again simplify this expression as sin square theta plus cos square theta plus tan theta. So now if we look at the left hand side, which is now simplified, and compare it with the right hand side, which is 1 plus tan theta, it seems that these both sides can be equal if somehow we can prove that sin square theta plus cos square theta is equal to 1. And then only the two sides will become equal, right? So let's hold on to this question for some time now and try to derive this relation, and then we'll come back to this question. And to start with the derivation, we will take the help of famous Pythagoras theorem. So we consider a right angle triangle. Now let's recall what Pythagoras theorem says. It says that the sum of the squares of the two sides which are adjacent to the right angle is always equal to the square of its hypotenuse. Now we will divide this relation throughout with hypotenuse square and we'll get, on rearranging we can write, so by looking at these trigonometric ratios, we say that this is nothing but the sine ratio, this is cos. So we can further write this as sin square theta plus cos square theta equals to 1. If you remember, this is what we wanted to prove. So if we go back to the third question where we have found the expression sin square theta plus cos square theta, we can put its value as 1. So now we are through because left hand side and right hand sides are equal. Now please note that sin square theta plus cos square theta will always give us 1 for any value of theta. For example, when theta is 30, 60 and so on. And if you remember, just now we have learnt whenever an equation is true for every single value of the variable, it is called an identity. So this is also a trigonometric identity. So friends, just like this, we can again make use of Pythagoras theorem and can get two more identities. All we have to do is, we have to divide the same Pythagoras relation once by opposite side square and then by adjacent side square. And we will follow the same steps as we have used in the first identity. And we will get cosec square theta minus cot square theta equal to 1 and sec square theta minus tan square theta equal to 1. Now let me tell you one more important thing. As Pythagoras theorem is the first step in getting these three identities, hence they are also called Pythagorean identities. So friends, I hope now we have understood that trigonometric identities are very important to learn and use properly. And there are many different trigonometric identities which can be obtained by using these three. But these are the ones that we use most often. So to remember these three, we will have to remember only sin square theta plus cos square theta equals to 1. And to get the other two, just divide the same by sin square theta and then by cos square theta.